Welcome to Brain Vision.
In this exercise, we're going to use the concept of force. So before diving into the exercise, I'm going to briefly write here Newton's second law that tells us that the sum of the forces that act on an object is equal to the mass times the acceleration of that object. So this is the concept we're going to use throughout this exercise. In the exercise, we have a block A, according to the figure here, that has a mass of 4 pounds and a motor that pulls block A up, according to the system of ropes and pulleys, such that the initial speed of point B here is equal to 0 feet per second, while the final speed of point B, is 10 feet per second after a time of 5 seconds. Given this information, our goal is to find what is the tension T of the rope at point B. Okay, so how do we go about solving this exercise? Well, first, we need to draw a free body diagram on block A. So here we have block A. The forces that act on block A are the weight force, mg and ag. Then we have the tension force that pulls it up. And we have that the tension at block B, which I'm going to call TA, minus MAG is equal to the mass of block A times its acceleration. So there are two things that we need to find out before solving this equation, because we still don't know. First, we don't know what TA is as a function of the tension at point B. And second, we don't know what the acceleration is. So let's start by the acceleration. So first, let's find what is the acceleration. Okay, so notice that at point B, the speed changes from 0 to 10 feet per second in 5 seconds. So the acceleration at point B is equal to delta V divided by delta T. So that is equal to 10 feet per second divided by 5. So this is 2 feet per second squared. This is the acceleration at point B. Now, how does the acceleration at the block A relate to the acceleration at of point B? Notice that due to the system of ropes, so here we have a pulley, and here we have point B. Due to this system of ropes, the distance that the rope travels or moves at point B, which we will call dxb, is equal to, and let me call the pulley point C, 2 times the distance by which point C is raised. Okay, because there are 2 parts of the rope that are around point C. So this means that point C will be raised 1/2 of the distance that point B that travels. Okay, so this means that the velocity at point B is equal to 2 times the velocity at point C. So the acceleration at point B is equal to 2 times the acceleration at point C. Now notice that point C is connected to the block A, such that the acceleration of point A is equal to the acceleration of point C. So this means that the acceleration of point A is equal to 1/2 of the acceleration of point B. So the acceleration of point A, which I'm just going to call A, is equal to 10 divided by 2 feet per second squared. So this is equal to 5 feet per second squared. This is the acceleration of point A. Okay, so we found the first thing we needed. Second, we need to find what is the relation between the tension at block A and the tension at point B. So first, I'm going to use the same figure here. Notice that the block, the rope that connects point B to pulley C is the same rope. So this means that the tension is the same throughout the rope. So at point C, we have 2 times the tension T that acts at point B, pulling the pulley C upwards. And we also have the tension TA of the rope that connects the pulley to block A, pulling the pulley C downwards. And since the pulley is massless, it's perfect. We have that 2 times T minus TA is equal to 0. So 2T is equal to TA. Okay, so, and T is the value of the tension at point B. So now we are in a position to solve our exercise. So let's go back to this equation here and substitute all we know into it. So first we know that TA is 2T. So I have 2T. Second, MA is 4 pounds. So I have 4 pounds times the acceleration of gravity, which is 32.2 feet per second squared. And this is equal to the mass, which is 4 pounds, times the acceleration, which is, and I'm sorry, before I had written that the acceleration at point P was 10 feet per second squared. Of course, that's just the variation of velocity. The actual acceleration was 2 feet per second squared, as we had written here. I'm so sorry for that. So the acceleration at point A is actually 1 foot per second squared. So I have that the right-hand side is 4 pounds times 1 foot per second squared. So T is equal to 4 pounds times 33.2 feet per second squared divided by 2. Now I'm gonna transform this to pound force. So remember that there are 32.2 pounds times foot per second squared in 1 pound force. So T is equal to 206. And I'm sorry, actually, it shouldn't be 4 pounds. Sorry for that as well. The mass is 400 pounds. So basically, in this last step, we have to multiply the mass by 100. Okay, now everything is correct. So the tension is 206 pound force, which is the answer to our exercise.